Hello everyone. Hello, good evening. This is Shatarupa and welcome to Rasayanika. So this is our fourth live session on CSIR NET June 2021 question paper discussion. So before starting this, I want to know from you also, am I audible? If I am audible, please type in the comment box so that it will be visible to me. Am I audible? Okay, so maybe no one is there, but I think I should wait for 1 minute so that they can join. And after that, I will discuss the CSIR NET June 2021 question paper. Every day, actually, we are discussing questions regarding this CSIR NET, which was happened during this February month in 16 February, actually. So, we are every day we are discussing some questions on that question paper. So, today is our fourth day for the question discussion session. It is a fourth live session. So, so let's start with our first question, today's first question. Okay, so this is our first question. The question is on, it is on physical chemistry basically. So the question was, for a microcanonical system, the correct probability distribution function for energy is given by. The question was asked in this CSIR NET examination, that was for a microcanonical system, the correct probability distribution function for energy is given by. There the options are option A, exponential distribution function. Option 2 is Gaussian distribution function. Option 3 is Poisson distribution function. And option 4 is uniform distribution function. Okay. So, anyone would like to answer this question? It was a pretty simple question on physical chemistry, basically on statistical thermodynamics. So, it is our first question for today's discussion. So, anyone if there, so please type in the chat box so that it will be visible to me and I can proceed. Okay, so I want to repeat this question again. This is for a microcanonical system. The correct probability distribution function for energy is given by this actually actually you have to answer which is the correct option among this for microcanonical system. Okay, so the options are exponential distribution function, Gaussian distribution function, Poisson distribution function, and uniform distribution function. Okay. So option 1, 2, 3 and 4. So what will be the correct option? So it's a pretty simple question because this is on statistical thermodynamics and you have been asked here about the microcanonical system, right? So you have been asked here about the microcanonical system. So you know there are so many canonical systems like microcanonical systems, macrocanonical systems and grand canonical systems like this, okay? So for microcanonical systems, you know there is some pretty simple thing like this. Yeah, you can find in any, considering any book of thermodynamics or statistical thermodynamics, there it is pretty simple. In microcanonical system, actually what happened, we are taking the system like n particles, n are the number of particles, these are the things, and the energy is E we consider, and also the volume is V we consider. Okay, so E, N and V, these are considering for the microcanonical assemble, and so this is the main thing is the uniform distribution is for the microcanonical system. Actually, you have to remember these things. For microcanonical system, this is always the distribution is uniform distribution, okay? Not the Gaussian or Poissonous or any other distribution. Only it follows the uniform distribution for microstates and for the microcanonical system actually. And for the grand canonical and canonical system, this the distribution will be Gaussian distribution, okay? So you just have to remember these things. It's pretty simple. So the correct option will be option 4. Okay. So correct option will be option 4, that is yes, uniform distribution. I know so many students among you have already answered this question in the examination like Gaussian distribution. Okay, so but this is not. This is not correct. This is a completely incorrect answer. And also it is not exponential distribution also. Not the Poisson's distribution follow. Okay, only this is what for microcanonical system. This is uniform distribution. Okay. So this will be the correct option because we are taking here for microstates, that is n number of particles, V is the volume, and E for the energy. And for this type of system, already by definition we know this follows mainly uniform distribution. Okay. So here you can see I have taken a slightly apart from actually statistical thermalism from the definition, actually from any recommended book you can see there is mentioned uniform distribution. Okay. Okay, so are you getting my point? There is anyone who would like to answer this or comment anything? So if anyone is there, please comment in the below comment box or the chat box so that it will be visible to me and I can proceed. Okay, so let's move to our next question. Yeah. So this was another question on physical chemistry. So this is another mathematical numerical problem actually. Okay. So this time physical chemistry was little bit hard. I will not say that hard, but the calculation was somewhat lengthy for some questions, and for some question it was like if you have some general knowledge or have some concept about that particular thing, only then you can answer those things. So this time physical chemistry question not like that straightforward, but yeah, the question was a standard level. All questions were in a standard level. So this was another question. This was from your ionic strength question. So the question was asked in the examination, that is the amount of BaNO3 whole twice, that is barium nitride. That is they have asked, that is what is the amount of barium nitride. Okay, where the molecular weight already given, and they ask that what is the amount of barium nitrate required to be added to 500 gram of a 0.11 mole per kg solution. 0.11 mole per kg solution of what? That is KNO3, in order to raise its ionic strength to 1 is approximately what? That is, they asked here about the amount, that is of BaNO3 whole twice barium nitrate, this salt, what is the amount is required to add it to the 500 gram of a 0.11 mole per kg solution. So what is here that is given? In the unit that is you are seeing here, the unit is mole per kg. That is the strength of the solution is given in the molality. Okay, mole per kg means molality. Per kg, what is the number of moles is present there, that is we call the molality. So you have been answered here, you have to answer here in terms of molality. Okay, so the amount of the barium nitrate is asked here, and it is said as a whole the total ionic strength will be 1. Okay, for both KNO3 and barium nitrate. So what will be this? Would you like to answer this question? Anyone is there? If anyone is there would like to answer this, it's actually intellectual question, I can say, not actually straightforward. Just you need to follow some specific way how to solve this. Then you will reach to the answer. Okay, so anyone from you would like to answer this? If yes, please type in the chat box so that it will be visible to me and I will proceed. The options are actually, option 1 is given in the question is 38.8 gram. Okay. And option 2 is, that's option B, that is 19.4 gram. Option C is 76.2 gram and option D is 126.5 gram. Okay. So would you like to answer this question? Okay, so if no one is there, would like to know, you would not like to answer this question. So I want to solve this question. So let's see how to solve this type of question, how to reach to the correct option. Okay, so basically, just look at the question. So you have been asked the amount of the barium nitrate which is required. Suppose, let's say you just consider this, the amount is X. Okay, let X gram. Okay, so you need to find this X. Okay, so let's move to our solution. Yeah, so let's you have been yes, you consider the required gram of barium nitrate, that is X gram. Okay, so now you have been just see the question, you have said there that yeah, in order to raise its ionic strength to 1 is approximately what? That is, you need to say here that is the total ionic strength of the total solution will be 1. So what will be the amount of barium nitrate in order to keep this ionic strength total as a total 1? So basically, the equation is what like this. The total ionic strength I equals to ionic strength of KNO3. That is in the solution, the both salts are there, right? KNO3 and the barium nitrate. So the total strength will be like summation of the each of ionic strength, that is I of KNO3 and I of barium nitrate. Okay. So what will be this? So you need to, at first you need to solve this. You need to calculate the value of ionic strength for the KNO3, and then you need to find the value for the ionic strength of barium nitrate. Okay. So let's see one by one. For at first we start with the KNO3 part. So we know that the ionic strength formula is looking like this. That is half into summation of, you all know this, half into summation of Ci into Zi square. So what is C and what is Z? The C means the concentration of the solution, that is the salt which we are taking in the consideration, and Z is the charge. Okay, so this is the basic formula for the ionic strength. You all know this, right? So here for the KNO3, what will be the concentration? Here it is also, see the question, it is also there given in the question. Yeah, this 0.11 mole per kg. Okay, so molar concentration is given here. Yeah, so C for the KNO3 is 0.11, and what is the charge? Yeah, for the different charges present there, that is K plus and NO3 minus, right? K plus and the NO3 minus. Okay, so for K plus that means plus 1 charge, and for NO3 minus that means minus 1 charge. So just put here, suppose the concentration value is M, we have taken here, suppose we have taken here M, then we will see that half into M for the K plus, M into plus 1, that is plus 1 charge is square, plus M into, that is for the NO3 minus, that is minus 1 square, because it is minus 1. So just add this and divide it by 2 and we will get the value. So we will get, by calculating this, we will get the M value, that is 0.11. It will come M. So it is given in the equation, that is 0.11. So just put it here. Just put it here. So we will get the ionic strength for the KNO3. Now we have to find the ionic strength for the barium nitrate. So just suppose we have already considered the required amount of barium nitrate will be X grams. That is what they have asked already. Okay. So what will be the ionic strength here? So at first we need to consider the strength, right? For the barium nitrate in the solution, what will be the strength? Yes, it is pretty simple. Just X divided by its molecular weight, that is given in the molecular weight in the question, right? 261.32 AMU. Just divide by this 261.3 maybe, right? 0.32, yes. Just 0.32. And you have to then divide or multiply by this. What? There is also consider the 500 gram, right? Yeah, just see this. What will be the amount of the gram? Here is asked in the question, that is 500 gram, right? So 500, and you need to consider it into the per kg, that is into the kilogram. So just divide this by 1000. So if we divide this by 1000 by 500, then we will get the 1000 in the above, in the place. And if we consider this, if we calculate this, we will get this. Yeah, the similar thing is this. We will get this value. Okay, just calculate this as multiply, or this calculating this, we will get this thing. So at the last, we can calculate, not in between. We can calculate it while solving in the last part. Okay, so just just keep it as it is. Okay, so here now we have to consider what the I value we need to find. So for I, we know that is half into m. M is already this. M is already this, right? So m into plus 2 square. Why plus 2? Because for barium nitrate, we can see barium 2 plus, and nitrate is 2 nitrate ion is there, right? For each is minus 1. So we are taking like this. It is 2m, and this is, yeah, this is 2m, and this is m. And if we calculate this, we will get the 3m. And already m is there. This value is m, right? Already we have calculated the strength. So just put the value here. So we will get like this: 3x divided by 130.66. If we calculate, we will get this value. Okay. So now just put here the value. Yeah, this is for barium nitrate, the ionic strength, and this is for the KNO3. And we also know that in the question it is also told that the total ionic strength will be 1. Yeah, so it will be 1. Just now solve the equation. Yeah, this 1 equals to 0.11 plus 3x by 130.66. Okay. So if we solve this, we will get the x value about around nearly like 38.8 gram or 38.9 gram, like this. Okay. Yeah. So this is the answer. The option 1 is the correct option. Yeah, 38.1. This is the correct option. Option 1 will be the correct option. So are you getting my point? Veronica. Okay. Hi, Veronica. I couldn't get you what you have typed there. So can you please again type there so that I can see what you have written there. Hello, good evening, Veronica. So I think this question is clear to you. Are you getting my point? Am I clear to you? This was a pretty simple question. This was from your ionic strength, a mathematical calculation based question. So we have already discussed this here. Okay. So if I am clear to you all, so I would like to move to our next question. Yeah. So this is our next question in this current CSIR NET Chemical Science question paper. Yes. So our correct the second question was third question actually. Today's third question was on the quantum, and this is only based on the commutator problem. It was a pretty simple question. This by this time these quantum questions were somewhat pretty or somewhat simple type of questions from the quantum part, not the hard questions were asked in this time. So this question was from commutator. So the question was the commutator x cap px square. This commutator is equivalent to what? Basically, you have to find this value of this commutator. This is a pretty simple question. The options were minus 2i h cut px cap, 2i h cut px, minus I h cut px, and I h cut px. Okay, so which will be the correct option? Anyone would like to answer this question among you? If you would like to answer this question, please type in the comment box so that it will be visible to me and I can say whether it is correct or not. It was a pretty simple question. Okay, so let's jump to our solution. How to solve this question? The correct option actually will be what? Yeah, this will be the correct option. 2i cut px cap. Okay, so how we will get this answer? So you need to find the solution, right? X cap and px cap square. This. How to solve this? So there are various ways actually there. So how we can solve this, but I would like to suggest on the simplest way. So you need to remember a formula to solve this type question, that is x and px square, right? If you have been given this type of commutator, the formula for this is n I into I h cut into px to the power n minus 1. This is a formula basically how we will get the value from this. If you haven't given like this x px square, that is here the square is n, okay, 2 is n, here's a 2 is n, like this. If you have been given there, the formula will be like differentiation. The formula will be like simple like differentiation. So ni, that is here the 2. So we will get here from this like 2 if we get this outside. So 2 px ih cut, because the formula is like this. And px to the power n minus 1 means 2 minus 1, we will get 1. Okay, this will be the correct option. And another way is how we can solve. Another way is just uh, just take out this square, like square term, like 2 in the outside, and one of the px. There are two px, right, in multiplication form. So take just one outside the commutator box. So now you have the commutator of x px. You have to find this. So how to solve this? You can again solve like this. That is, just multiply like this x px minus of pxx, right? So p means how the p is, that's a differentiation term. Okay, so just follow this rule and you will reach to the answer. But the thing is, if you follow this rule, it will take so many time, much time actually. So why to waste the time during your examination? If you know this particular formula, the simplest thing, you can easily solve this. Or whether in another case, you can also remember these things. This, if you calculate this commutator again, the value will come as 1. Okay, ih cut 1, ih cut 1. So it can, again we can solve this. So the best way is to remember this formula for this type of particular equation, commutator, how to solve. Just use the formula and you can reach to the answer. So now that's how you can save your time. Okay, so am I clear to everyone? So answer 2 will be the correct option. Yeah, this will be the correct option. Answer 2. Option 2. Okay. So am I clear to everyone? It was a pretty simple question. Okay, so if I am clear, so I would like to move to our next question. Okay. Yeah. This is our fourth question. The fourth question is the number of microstates corresponding to the atomic term symbol 4F is given by some options and you have to answer which is the correct option. So number of microstates corresponding to the atomic term symbol 4F. So you have been given the term symbol 4F and you need to answer what will be the number of microstates. It's a pretty simple question. It is another question from inorganic chemistry. Okay, Papri has answered, yes ma'am. Okay, so that means maybe for the previous question, so she got my answer or she understood. Okay, so this is our another question, Papri. You can follow this. So this is from inorganic question, and the question is the number of microstates you need to calculate. And for what? That's the term symbol is given here. That is 4F. And the options are 7. That is option 1. Option 12 is the option B or 2. 28 is option C, and 42 is option D or the option number 4. So what will be the correct option? Anyone would like to answer this question? Please type in the chat box so that it will be visible to me and I can proceed. Okay, so let's move to our solution, how we can solve this. Yeah, it's a pretty simple. So you need to remember a basic formula for this, that is the number of microstates will be 2s plus 1 into 2l plus 1. Okay, this the formula is, there is a simplest formula. So 2s plus 1, you need to remember this, 2s plus 1 into 2L plus 1. I think it is visible to you. You can understand this, the writing. If not, then you can see from here, that is the circular or mark part. Okay. So here, so what is 2s plus 1? This is basically nothing but multiplicity. Okay. Multiplicity. Multiplicity, this is 2s plus 1. Okay. And L, you have to find these values. Okay. So for 4f, we have given like this. The multiplicity is 4 is given here. 2s plus 1. That is 4 is given here. So put the value here, 4. Okay. And another thing is 2l plus 1. So L, what is the L value? We have f here, right? So what is the L value for this? For f orbital, the L value is 3. We all know this. It's very simple. So just you need to calculate this. So L value, if the value is 3, then it becomes 3 into 2, that is 6 plus 1, that is 7. And just multiply 4 into 7, you will get 28. So the number of microsteps will be 28. And the option 3 will be the correct option. Yeah, 28. Okay, it's a pretty simple question. It is from your atomic structure or term symbol question. So the question, the option 3, 28 will be the correct option. So, are you getting my point? Am I clear to everyone? Okay, if yes, then I would like to move to our next question. Yeah, this is our fifth question. So our fifth question is, when yellow phosphorus is converted to red phosphorus, the entropy and volume of the system do not change. That is, the entropy of the volume of the system do not change. That is already given, the information is given in the question. The order of this phase transition is most likely to be. So they actually asked about the order of the reaction, right? Okay. So the reaction is like phosphorus is converted from yellow to red, from yellow to red. Okay. So you need to answer what is the order of this transformation, that is phase transition. And also another information is given there, the entropy and the volume of the system do not change. That is delta S equals to 0 and also delta V equals to 0. Okay. So what will be the correct option? Anyone would like to answer this? Okay. So let's start how to solve this question. It's another question from phase transition or your phase diagram. Okay. From your phase diagram, that is physical chemistry question. So we all know this, when the both volume and the entropy change, both are equal to 0. Then basically when the delta S and delta V is 0, basically it is nothing but second order reaction. Okay. It's a basic thing actually. You need to know this. And I know and believe that you all know this, because in your just graduation, in your basic level, when you read this phase diagram, there we need to read this. That is when it is the basic conceptions actually. For the volume change is 0 and entropy change is 0, that means it is talking about second order reaction. Okay, so basically it was from your not only conceptual, I will say, to memory based question. So you have to answer like this, order will be 2. In another word, you can also solve like this. The how will be the F, like, so F is C minus P plus 2. The phase rule, you all know this. F equals to degree of freedom. F equals to C minus P plus 2, where F is the degree of freedom, C is the number of independent component present in the phase, in the equation, P are the number of phases, and plus 2. Okay. So put the things here. If you put the values here, the C is 2 here, because red phosphorus and yellow phosphorus, 2 independent components are there. And the phase are 2 phases. Okay. Though both phases are there, 2. And just calculate this, we can get the order, the degree of freedom will be 2. So the order of the reaction, again we can say like this will be 2. So basically you need to, if you remember this, the entropy and volume change will be 0, then you can easily reach to the answer. So basically it will be option 2. Okay, yeah, this will be option 2. So I am clear to everyone, right? It's a pretty simple question on phase diagram actually. If it is clear to you, then I would like to go to our next question. Yeah, this was our sixth question. Okay. So sixth question was, that is when three of the phase of a two component system are simultaneously in equilibrium, the number of degrees of freedom will be what? Okay. So they have asked here about the some degrees of freedom. That is, they told already when three of the phase of a two component system are simultaneously in equilibrium. Okay. So what will be the correct option? Anyone would like to answer this question? Is another phase diagram question, and this time they have asked all the phase diagram questions were pretty simple, were very simple. The phase diagram questions were very simple because almost those were straightforward, something like, and very simplest way we can calculate those. So okay, so let's see what will be the solution. So how to reach to the solution? So basically, the correct option will be option 2. Yes, this one. That is 1. Option 2, that is 1. So how we will get the value, that's degree of freedom will be 1? How? Yeah. We all know this phase rule. Just we are discussing here. In the previous slide, we also discussed here about the formula. That the phase rule, that is F equals degree of freedom equals to C minus P plus 2, where C is the number of components present there, P is the number of phases present there, and 2 plus 2. Okay. So C is given equals to 2. How? Yeah. 3 of the phases of a two component system. Yes. So that C is 2. It is given in the question. C is 2 and phase. 3 of phases, that is P is 3, already given in the question. So C is 2 and P is 3. So now, yeah, just put the value here. C is what? C is 2 and P is 3. So put the value and we will get 2 minus 3 plus 2 and we will get 1. So the degree of freedom will be 1. It is very simple question, and this time the phase diagram questions were very easy. So correct option will be, yeah, this option 2. Okay. So understood my point? If I am clear to you, then I would like to move to our next question. Yeah. So this is our next question. Yeah, our next question is it is another question from your actually quantum chemistry, I would like to say, rather than molecular orbital diagram. Okay. So the total pi electron density on the 4 carbon atoms of trans-butadiene are in the ratio what? So they have asked about the ratio. The pi electrons present, total pi electrons present in the trans-butadiene. So what will be the ratio? Shima also answered option 2, ma'am, in the previous question. Yes, Shima, it was correct option. I think she has answered for the previous question, not this one. Shima, are you answering for this question, 7th question or the 6th question? If you are talking about the 6th question, 6th number question, the option will be option 2. And if you are saying for the 7th question, then okay, let's see what will be the correct option. Would you like to answer this question? Anyone? Okay, so let's try to solve this question. Okay. It was another question from your actually quantum chemistry, physical chemistry, and on from your molecular orbital or homo molecular orbital Huckel's theory actually from there. Okay. So from there, when this question is asked in the examination, the students will think, I know, the students will start thinking like that they need to consider the wave functions and all, whatever, there's big things like that, and they need to solve these wave functions, and they need to consider the coordinate parts, also the coefficients for those. But I can say that you don't need to consider any wave function, don't need to remember any large like long type of wave functions, the complex things. No, you don't need to answer like that. You need to think in the way like that. Okay. So it was a pretty simple. If you see to the question and just apply a basic questions, you can easily answer. Okay, Shima already answered that 6 questions, ma'am. Okay, question number 6, you have answered the option 2. Yes, it was correct. Yes, Shima, for the previous question, the question option number 2 was the correct option. Okay. So now we are discussing here about the 7th question, and this is on our quantum chemistry actually. So they asked about the pi electron density. What will be the correct option? What will be their ratio? Okay. So how to solve this question? Basically, if you see, that is the butadiene means like this, right? Butadiene like this. So there are basically 2 pi electrons, 4 pi electrons, right? So the carbons are 1, 2, 3 and 4. This type of things, right? So there are pi electrons, like for 1 carbon there is 1, 2 carbon there is 1, 3 carbon there is 1 and 4 carbon there is 1. So there is symmetrical distribution for all the carbons, the pi electrons. Why? Because it is a conjugated system. We can see the conjugation. That is, pi electron can move here and also pi electron can move here. Another, it will come back and it will come back like this. So it's a completely resonating structure, conjugated system, the butadiene system. So, and it is also trans, right? It is also trans. So all the carbon atom, we can see that the electron distribution, pi electron distribution is same for all the carbons. Okay, and in fact for each carbon there is 1. So that's why the density we will write like this, 1:1:1:1. So I know the student will think to solve this question that there is a formula like this. This is for the electron density. Q, we all know that is summation of Nj into Aij square. That is, Nj is the number of electrons for each wave functions, or the each we can say the each energy level, and the Aij, it's square. That is the, what is this Aij? Aij is the coefficient. Okay, the coefficient for the wave functions. Okay, so by taking the summation for all this, you will get the Q. But you don't need to consider the coefficients of wave function, or don't need to remember the wave function. This is a pretty simple question. Okay, so just apply your basic knowledge and apply your basic concept about this, and if you know the structure, the butadiene, it was pretty simple. Okay, so you can usually reach to the solution, you reach to the answer actually. So it will be nothing but the conjugated system, and the same type of pi electron density is located on the carbon. So the ratio will be 1:1:1:1. It's simple thing. Okay, there is another comment. Eleanor, I can understand your comment, Eleanor. If you want to say anything, you can type again so that it will be visible to me and I can understand this, what you would you like to say. Okay. So I think it is clear to you all, this question. The correct option will be option 1. Yeah, this one. The correct option will be option 1. So if I am clear to you, then I would like to move to our next question. It is our 8th question. Yeah, this is another and new type of question, I will say. This is from your inorganic actually, group chemistry, but on inorganic chemistry actually. The question is, the reactive cross section is expected to be the largest for the reaction. So they have asked here about the reactive cross section will be largest for which? Number 1 is lithium plus Cl2 is LiCl plus Cl. Number 2 for sodium plus Cl2 reaction. Number 3 is potassium plus Cl2 reaction. Number D is, or 4 is rubidium plus Cl2. So it will be the correct option. Anyone would like to answer this question? This question? This is another, I can say, it's a new type of question in this year. It is asked. So basically, how we will solve this question? Let's see the solution. The correct option will be option D. Yeah, rubidium. But why? How we will get to the reach to the final answer or the option? Okay. So basically, this question this time asked from your harpoon equation. Okay, Harpoon equation. I know this term is new for you all. Actually, in the recent update in the syllabus, if you can see, this type of question is recently added, this type of things. So, this Harpoon equation is nothing but this is the equation. The equation tells about what? The difference of energy, ionization energy and electron affinity. So, the equation is E square by 4 pi epsilon 0 R, where the R is the cross section area. Okay, R is the cross section area, and it is equals to difference of what? The ionization energy of the element minus electron affinity, and that is equals to delta E, that is energy change, which is asked here. So the R is cross section area here. So if we want the largest cross section, if we want to get the value, this higher value, so it is basically inversely proportional with the delta E, right? So the delta E will be lowered. So how we will get the delta E value, the energy value, a low value, a lowest value. How we will get? If this difference part, that is in this term, if the ionization energy will be the lowest value, then this difference will be in negative signs and it will be maximum, and so delta E will be lowest term. So that then we will get the largest cross section value. It's a pretty simple concept, right? The denominator term, the R should be large. So in the numerator term, the delta E should be high value. That means in negative. We should have a negative value. That means it resembles that the R is in inverse sign. Okay. So how we will get? If the ionization energy will be lowest. Now we can see for the, here the question is asked, if you see the question, yeah, that is all are the metal atoms, right? Lithium, sodium, potassium, rubidium. So if we move down the group, we will see the ionization energy value will decrease. IE value will decrease. Okay, down the group, decrease. For the rubidium, it will be lowest value. Why it is down the group, it is decreased. For rubidium, why it is lowest value? Because the rubidium has the largest size, right? Largest number of shells present there. Largest size is there. So the ionization energy will be lowest for this. Yeah. So for rubidium, we will get its the largest R value, cross section area. So according to Harpoon equation, if you follow this is a basic equation of inorganic, basic conceptual question. So we will get the, for rubidium, the maximum cross section area. In another word, we also say like this, we can think like this way, that is largest reactive cross section, right? That is the more number of molecules or more number site of area that will be in contact to the reaction, right? So when that is, how it will possible? If the size is larger or the largest size, right? So then the surface, from the surface area will be largest, and then the more number of molecules will come into contact with the reaction. Okay. So in other words, if you don't know the Harpoon equation, in another conceptual part, you can also solve this problem. For this also, if you think like this, rubidium will be the largest R value, cross section. Okay, so you can easily answer this question. The option D will be correct option, option 4. Okay. Yeah. 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 The another thing is our next question. If you understood this question, I would like to proceed to our next question. That's ninth question. The question is another question from our, actually from our kinetics, mechanical kinetics. It's a pretty simple question, but the calculation is somewhat, you need to some understanding process. So the question was, the rate of decomposition of a gas is 10 millimolar per second when 10% is reacted. 10% is reacted when? The rate is like this, 10 millimolar per second. And 5 millimolar per second when the 40% is reacted. That is, the 40% also already reacted. Then what will be the order? So what is the correct option? Would you like to answer this question? Anyone? If you want to solve this question or answer this question, just type your option there. Okay, so we don't have much time, so I would like to solve this question. So let's see how to solve this question. Okay, so basically, how we can solve this question. This is a pretty simple concept we should apply there. That is, yeah. Here we have told already 10 millimolar per second for 10% reacted. That is, reaction is done 10%, and 5 millimolar per second is for 40%. So what is the order they have asked here? So you know this, the rate R is directly proportional with what? With the remaining concentration to the power n. What is remaining? A means remaining. What is remaining? If the initial concentration is A, small a, minus if the reaction, what the percentage is reacted, that is x. So we will get A minus x. This is A. Somewhat this is A. That is, and the power is n. Okay, so it's like this. So if you calculate this for the first term, 10% reacted. So what the remaining percent, unreacted percent? 90. Okay, so they put the value here. For R1, but take the ratio R1 by R2, that is A1, concentration of A1 to the power n by concentration A2 to the power n. So if they put the value rate R1 and R2, rate 1 and rate 2, we will get the value that is 10 by 5. 10 by 5, okay? 10 by 5. And for this, A means A minus X, okay, it's the remaining part. So if we minus from 100, the 10, it will come 90, not 80, sorry, but it become 90, okay? And for the 40% reaction, the unreacted percentage will be 60. So we will get here like this. The ratio will be like 10 by 5 equals to 90 by what? 90 by 60. So just cancel out these zeros and everything. If we calculate like this, we will get 1.5 to the power n equals to 2. From this time, I know you all are aware about this. That is, the electronic calculator is provided there. So every time it will be, from now, electronic calculator will be visible there. So you can easily calculate this by using calculator. So you have to take just log from both sides. You have to take the log from both sides, and you will easily calculate from log 1.5 and log 2. You will get the n value. Okay, from this, and the n value will be 1.71. Okay. The another way you can also apply to solve this, that is just approximation. This is called approximation way. Just take the value n equals to 0 once, and you will get 1. Okay, so this is not equal to 2, so it is not, cannot be. Another thing is n equals to, if we take 1, so we will get 1.5. Another, it will not happen. If we take 2, so it will get we will get 1.5 square, that is 2.56, like this. 2.25 maybe like this. So just see the options. So not the 0, not the 2.15 and 2.2. So between this 1 and 2, right? The answer will be 1.71. This is another way how to approximate the value, but I think this time you should use the calculator because they have already given there. So it will be pretty simple and much logical to use the calculator and calculate the value. So it will be correct. The option will be correct. 1.71, the option 2 will be correct. Okay. So if I am clear to you, I would like to move to our next question. Yeah. This is our 10th question and another question from our physical chemistry basically, and the question is asked here: for a person weighing 70 kg, the minimal volume in milliliter of a fatal dose of a compound with LD50, that is lethal dose. LD50 means lethal dose, is 80 milligram per kg, and the density is given 1.45 gram per ml. So what will be the correct option? So they have asked here about the amount of the mass. What is required gram? Is required gram in the gram of gram actually. What will be for that particular person? What will be the amount of dose? Okay. So they have asked here the volume actually. They have asked here in the volume term. What will be the minimum volume? So it's a pretty simple how to solve this question. If you see here, just see this. The lethal dose LD is given here, right? Lethal dose is, what is this? That is what is the amount of a dose is required to cause death what is the amount of that is lethal dose 50 means the amount of 50% of the dose which causes the death for a person. So that is given. This is mainly utilizing for the testing process of any new medicine or drug testing. So we use this type of techniques, lethal dose technique. So that is applied in any animal or anything like that. So that the 50% whether it will kill the animal or not, just to see this, to taste this. Okay. So this is lethal dose is 80 milligram is given. So what we need to do here first? First we need to calculate the mass. What will be the required mass for the amount of the lethal dose? What will be? For the person is weight is 70 kg. So how we calculate here? How we can calculate here? So basically, we can calculate like this 70, that is the calculation, that is the total weight of the person, and the lethal dose is 50, 80 is given here. Just multiply this. So LD value multiply with the person weight. Okay, so that will give the total mass of the amount of the mass or the amount of the dose. Okay, so 5600, that is 5600 milligram. Okay, so another comment is there, that is Rajrupa also answered. Very good explanation, ma'am. Thank you, Rajrupa. So stay with us till the end. So we are answering answering the questions of regarding this CSIR net. So this is another physical question. So first we find here the amount which is required for the dose. Okay, that is the mass. Another thing, now we need to answer this, the volume. So volume we know, that is mass by density. Density is already given here. So the mass is 5600 milligram divided by 1.45, and you will easily get the value of 3.9 ml. Okay, so option 2 will be the correct option. What is option 2? Yes, this one. Option 2, 3.9 will be the correct option. So understood everyone? Am I clear to you? If I am clear to you all, then I would like to move to our next question. Okay? Yeah. So this is our another question. This question is, consider the following terms, identify those which are relevant to DC polarography. Okay? This is from your DC polarography actually. So the question is which things are related to DC. That's in DC polarography which all are used, or the terms are used in the DC polarography while explaining those. Okay, Papri answered that yes, ma'am. Okay, so the previous question is clear to you. You have answered this. Okay. If it is clear, this is our another question. The question is on the DC polarography. So the options are thermal current, supporting electrolyte, depolarization, and gelatin. So which will be the correct option? Would you like to answer this question? Anyone? This question is a pretty simple question, and the correct option actually will be what? Yeah, option 3. For DC polarography actually, option 3 means this one. Okay, this one, option 3. B, C and D, that is supporting electrolyte B, is also related to DC polarography. C, that is depolarization, is again related to DC polarography. And the D, the last term is gelatin, is also related to DC polarography. So these 3 terms actually are very related or relevant to DC polarography. Supporting electrolyte is used here, depolarization term is used here, and also the gelatin is used here. This must be very important thing. So no need of thermal current. So option 1 A will be correct, cancelled out. So B, C, D are correct. So option 3 will be correct. Am I clear to you? Okay, if I am clear, then I want to move to our next question, that is question number 12. Yeah. So match the iron and copper proteins with biological function in the table below. This is another question from your match question, column match the column. So the proteins are iron protein. In the left column, there is iron proteins are given, and in the right column, the copper proteins are given, and in the next column, the biological functions are given. So you have to match this, that's which iron protein and copper protein have the similar type of biological function. Okay. So which will be the correct option? So it's a pretty simple question from your bio-inorganic actually. Bio-inorganic part is very, very important for your NET CSIR examination, you know all this. So this is a very, very important question actually, and it's a pretty simple but important question, okay. So what will be the correct option? Yeah, the correct option will be option 1. Yeah, this one. Option 1. Why option 1? Because in A column, that is iron protein hemerythrin, A to Z, that is hemerythrin, 2 means hemocyanin, and Z means oxygen transport. So hemocyanin, hemerythrin, and oxygen transport are these two proteins, that is iron protein and copper protein, hemerythrin and hemocyanin, both has a similar function of oxygen transport. And another thing is B3X, that means cytochrome P450, and the 3, that is tyrosine, and the X, that means oxygenase. They all have the similar function. And the another thing is risky protein is iron protein, azurin is copper protein, and another their function is electron transfer. Why? Okay. So these are the similar things. Papri has answered option 2 for this question, right? Option 2. Yes, Papri, option 2 is not your correct option. The option 1 will be the correct option for this question, match question. And if you are answering for the previous question, that is 11, yes, for this it will be the option 3. Okay. Okay, so yeah, I think I am clear to you. It's a pretty simple question from your bio-inorganic actually. Okay. Yeah. Now let's move to our next question. So next question is our last question, and this question is regarding your IR stretching frequency of the given molecules. So the structures are given here, the number of CO bands for the isomers from sets of 1 and set of 2 in their IR spectra. So you have to answer what will be the IR signals or the IR bands, CO bands. How many how many IR CO bands we will get for these structures? Set 1, they have asked here, they have told here actually, trigonal bipyramidal, isomer, axial and equatorial. So when it is axial, we can write like this. Axial means Fe, here it is CO, here also CO, and the L is in axial part, right? So here, the structure will be like this. So you need to remember when the L is in the axial position, then it will give what? That it will give the three signals. Okay, already the 3 signals. The option 4 will be the correct option. Option 4 will be the correct option. Yes, it will give the 3 when it is in axial. Why 3? Because you have not been mentioned here about the collinear or not. The CO bands will be, ligands will be there, collinear or not. If you have been not considered, or if you have not been asked there or told there in the question that the CO will be collinear or not. If collinear, then it will be 2, and if not collinear, that is not told here, right? Not mentioned here. So you can say it will be 3. It will be 3. And for the equatorial means the structure will be like this. It is Fe, it is CO, it is CO. Here it will be CO. Sorry, now equatorial, right? So here it will be L, and here it will be CO, and another here it will be CO. So for the equatorial, if the L ligands will be in equatorial position, then the stretching the CO bands will be what? 4. It will be 4. And now if we consider for the FAC isomer and the MER isomer, for FAC isomer it will be always 2. You need to remember this actually. And for MER isomer, it will be always 3. So you can answer this question if you know this, that is the IR spectra, that is what will be the depth. If the CO bands for the isomer 1 and 2, that means the axial, The CH band will be axial position. If the ligand is in axial position, always it will give 3 bands. And if it is not collinear, so if it is not been mentioned here, so you can easily consider that is it is not collinear, so it will be 3. And for the equatorial position, it will be always comes like 4. And for the FAC isomer, it will always comes like 2, and for the MAR isomer, it will be 3. So if you know this basic stretching frequency and the structures, you can easily answer this question. This was our correct option, okay? So I am clear to you? If I am clear to you, this was all the questions we have asked here. So I think I am clear to you all. I have already discussed these questions. So again, tomorrow we will again bring some questions, and every day we are discussing the chemistry questions regarding this CSIR NET examination, and we will again come back tomorrow with some new questions. Okay, so I think everything is clear to you. So I think I want to mention just another thing here, that is we have already started our batches or classes for the CSIR next CSIR NET examination, and every day in the morning batches actually started, and from 4th March the batch has been already started. So you can just join our class, and you can just see the links in the given in the comment box, and you can join those. Okay, so for till then, thank you everyone and good luck. Bye.